not only YouTube, but also on our website. And I think most people look at it on the website. Anyway, it takes a second for it to get going. And not only YouTube. All right. So it looks like we are live. And let's go. Hi, I'm Meta Spencer. Today is going to be a special day. We have some very eminent people who know a lot about clouds. And before we're through with you, you're going to know more about clouds than you do right now. I promise you. Because clouds are important, and you are undoubtedly concerned about saving the planet from global warming. And that one of the best ways of doing it seems to be to whiten the clouds. So how would we possibly do that? Well, we'd spray probably salt water into the clouds, or let it go up to the clouds. And if we do the little particles just right, they will be the little salt will be up there, and it will attract more drops of water, and they'll be small enough to be whiter than the other drops around them. And the whole cloud will be just a little bit whiter and will reflect a lot of this incoming sunshine. So we don't get it quite as much sunshine landing on Earth or on the water. So that's the general idea. It's called marine cloud brightening. And I have three very eminent experts on this topic who already know each other, and they'll be talking in a very friendly way, I think, because they undoubtedly have had a lot of conversations about this topic in the past. I'm going to go in the order in which they appeared on my screen. And the University of Cambridge is Professor Hugh Hunt, who's an expert on the best thing is he's the keeper of the clock at Cambridge University, and that is all you need to know about this man. But he does mechanical engineering, I think is the title. And in Jerusalem is Professor Daniel Rosenfeld, who is an emeritus professor from the Earth Sciences Department of the Hebrew University of Jerusalem. And he no doubt I understand, has spent time on a boat near Australia, spraying salt water into the clouds. And that's going to be, I haven't talked to anybody lately who's been on that boat, so I want to hear more about what it's like. And let's see, where is you? Oh, UBC, yes. Professor Steve Rojak, who is a professor of mechanical engineering, I believe, at the University of British Columbia in Vancouver. And he is an expert on aerosol. Aerosols are any little particles in the air, except water, as I understand it. And if we spray salt water, and we will leave little particles of salt in the air, and those will be aerosols. So that's why he is interested. Okay, fellas, how shall we start this? Because now I've tried to give a very quick summary of what marine cloud brightening is. Let's see if we can get somebody who's got some news to share, because I haven't done a talk show for several months about marine cloud brightening, I don't think. And so I'm not up to date. I know that some new things have been going on. So maybe somebody can bring us all up to date about what the experimentation or even legal changes, any kind of political or legal changes having to do with marine cloud brightening. What's been going on the subject? Does anybody help me with this?
Well, who's up to speed with what's going on in San Francisco at the moment? Because there was an experiment on marine cloud brightening that got underway with great fanfare. New York Times reported on it, various other places reported on it, and then it got put on hold But my understanding is that as of a day or two ago, it's no longer on hold.
Mhm.
I'm not up to speed on that. I don't know whether either Steve or Danny know more about that.
Yeah, what I know is that they did it on board of a carrier, and they didn't aim at the clouds yet. They just tested the mechanism of spray and the environmental impacts of that. And finally, the authorities reached a conclusion that they cannot make up the difference between natural sea spray and artificial sea spray. Not a surprise.
So don't worry, it's not going to hurt you.
Yeah, and indeed, the concern potentially from the local authorities was that emitting particles would be a potential health hazard. And then after doing their own more careful review, they concluded that yes, this is a little bit like all of the sea spray that's coming in over San Francisco every day in tons and tons. So
Mhm.
that's as expected.
Mhm. So they haven't, you don't think they've done the real experiment yet, right? And they will be doing it shortly. Is that the idea, or has anything already happened?
As I know, they are just developing the gear for that now.
Mhm.
But the person who to ask that is Rob Wood from University of Washington. He's in charge of that.
Mhm.
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 But it is interesting that the whole purpose of this is that, I mean, nature produces sea spray. Whenever there's waves and wind and we get droplets of salt water in the air. And those little droplets, they dry out in the air and they produce little salt crystals and they move up into the clouds, and they help to nucleate the clouds. The thing that we want to do, I guess, is, if we think of our clouds being nucleated by little crystals of salt, then the size of those crystals of salt matters. And if we can make smaller salt crystals it produces, then those smaller salt crystals nucleate smaller droplets in the clouds. And because there's only a certain amount of moisture up here, smaller droplets mean more droplets. And more droplets mean perhaps a bigger cloud of smaller droplets. And smaller droplets are more reflective. So there's all sorts of reasons why making little droplets, little
Mhm.
salt crystals is a good thing. So what they're doing in San Francisco on their boat is to see if they can figure out a way of making a spray of salt water to produce smaller crystals. Now, a real question for us is, what is the right size of
Mhm.
those salt crystals? And I know that Danny's got have been doing a lot of thinking on the right size. And then a question that we in Cambridge, and I know that Steve has been working at, is well, how do you go about making salt crystals of the size that you want?
Mhm.
And then there's all sorts of questions about, well, if we make them, how long do they last? Should we do it in the Arctic, or should we do it in the tropics, or should we do it in the morning, or should we do it in the evening? There are so many questions that this experiment that they're doing in San Francisco and also in Australia, similar things,
Mhm. Mhm.
helping to answer some of these questions.
Well, for
Mhm.
one thing, you taught me one thing that I didn't know already, which is that the clouds get bigger if they're whiter. I didn't know that if you have smaller crystals, the clouds get bigger.
Well, maybe that's wrong, Danny or Steve.
I can take this question. Well, first, when you get natural cloud drops, or cloud drops cannot form spontaneously when the air rises and becomes saturated. They must form as dew form on the ground at cold nights on pre-existing particles. That's why when you have more particles, including these sea spray particles, you have the same cloud drop concentration, the same cloud drop, the same amount of cloud water is distributed among larger number of smaller droplets, and that's what already you said. But the point is that when you break one drop to many small drops, you get more surface area combined. And since the solar radiation is reflected from the surface area, the enlarged combined surface area makes the cloud brighter. Now, when the cloud drops are smaller, the cloud is slower to precipitate because the large drops also are falling faster and make rain faster. And if the cloud doesn't lose the water to precipitation, it can last longer and cover larger area, and that is another benefit to reflecting more solar radiation back to space. So we have two effects. One is the brightness effect, and one is the area effect.
Mhm.
I guess the
wanted
third
to-
benefit, which you mentioned, is also that they last longer in that they're there for longer in time.
Yeah, but we can the time and space are exchangeable.
Okay.
What do you
I
mean?
wanted to pick up a thread that we sort of started on a little bit, talking about the Bay Area experiment. I think there are at least three major issues that you have to deal with marine cloud brine. One is forming the right size particles. That's kind of an engineering problem to design the atomizers and the delivery system. Another is understanding what particles of different sizes would do in the atmosphere in different conditions. And a third one, which really relates to how things played out in the Bay Area with the temporary ban on the experiment, is how people perceive this approach to climate repair and how to communicate it, and how to put it into the context of all the other things we should be doing to mitigate climate change. So when I talk to colleagues, for example, many people are really quite opposed to the idea of injecting anything artificially into the atmosphere. And that's of course something you have to be concerned about, but it's a real barrier to this kind of approach to climate change.
Have you talked to anybody lately about whether all of this flap that's been going on, I presume that it's got a lot of publicity in the Bay Area. It's in Alameda, which is the East Bay. I used to live in Berkeley for 40 years. So anyway, has this changed public opinion at all? Because I think you're right. Of course, that's a big problem that so many people, the majority maybe, we don't know. Not, I believe not the majority, but a lot of people are really opposed to anything that is mechanical or interfering with natural processes. And if they hear a little bit more about it, they tend to change their minds. So this may have influenced public opinion a bit, do you think? Or do you know anybody there? I haven't talked to anybody in the Bay Area about it. Have you, or any of you?
Well, I have a friend who's a professor in atmospheric sciences at Berkeley, and I know that like me, he's been following this issue for many decades, and probably like me, has been firmly of the opinion that we need to reduce emissions, and that's our primary approach to this. I don't have any solid statistics to back this up, but I feel that there's a kind of demographic or age-related correlation here, that if you've been following this issue for 30, 40 years, you appreciate that we haven't really done enough globally to reduce emissions, and it's getting pretty late. Whereas if you are much younger, you may look at some of the hopeful signs that are coming out of the climate conferences and think that we're just around the corner from solving the emissions problem. I don't know if this is true, but it seems to fit the pattern for some of the conversations I've had with younger colleagues. So I'm not sure what Hugh or Danny think about that, but
Well,
Sorry, go ahead.
okay, I think that the best way to describe the situation is that so far we have business as usual with respect to using the fossil fuel, and the global warming is accelerating frighteningly. At the same time, there is the moral hazard. The moral hazard is called when we may have artificially decreasing the global temperature by geoengineering, say by seeding sea spray, then it will take off the burden from the leaders to reduce the greenhouse gas emissions. And that is something that should not happen. And there is a consensus presently that we should not decrease the global temperature by geoengineering yet. But at the same time, it would be irresponsible not to develop the technology to be able to do so should everything else will fail and will come to a real climate emergency, like a catastrophic meltdown of polar caps, major cities get drowned and so on. Then everybody will scramble to that, and it will be irresponsible to then be unprepared. And that is sufficient justification to develop the technology presently.
Mm-hmm. Sounds good. I should introduce my friend Adele Buckley, who's joined us a little late. Adele is
sorry about that.
Yeah, Adele is a friend from my Pugwash community and is an engineer and a physicist in her background. So she will probably have comments to make about this. If I may, I'd like to ask, because the obvious reason for not doing marine cloud brightening is that it's dangerous, and we don't know how dangerous, if at all, it is. So I understand that there's a real possibility that creating more clouds will create more rain. It might be in Asia, it might be in the Sahara Desert. I'm not sure where, but the question is, can anybody give some realistic appraisal about whether or not any modeling has been done that would indicate whether or not there might be the use of marine cloud brightening might cause floods, or if you have any knowledge of any other danger that we may have been overlooking, we should talk about that. I don't think that we have much discussed whether there's anything realistic to worry about. Oh, Adele has got her hand up. Yes, Adele.
Well, I think modeling is a good topic too, but the thing I want to say, I guess Meta knows me as apparently a pessimist, and I'm not. Really, I do believe that geoengineering will be required, but it seems a very long way until it's ready. I have never seen, but maybe it exists, data that shows that cloud brightening actually cooled a piece of ocean that anybody has produced and verified by an independent third party. I think, that could be really important. The other thing is, of course, I hear that we need a right-sized nozzle to get the effect that we're seeking. Great, but there seems to be a lot more to it than that. So I say things like, well, it's going to take so much greenhouse gases to just do this work that it could balance out in a wrong way. So then someone tells me, oh, well, we'll use wind. Well, that's nice, but what I would like to think of is that some engineering department is designing a unit that would sit in the ocean, powered by wind, and spray the appropriate size spray. That seems to me that's fielding of all these many units would actually do something. But this is a big job. This is not a trivial thing to do, and no one's trying to do that so far. No one's producing numerical data that I know of. So we seem to be a long way from doing the geoengineering. But
Well, let's see what
I
you
just
what
want
you
people
have
to
say.
be realistic about when it can be done.
Yeah, all right. Hugh, give her the answers.
So I totally share all the concerns that have been expressed so far, but I kind of think it's a little bit like I think of Apollo 13 when it's spaceship Apollo 13 was on its way to the moon when they had a bit of a disaster, and they didn't have much time to figure out how to get these three astronauts back safely to Earth. And the story, we know what happened. They did come back safely to Earth, and it was pretty amazing. But all of the dozens of things they had to do to get these astronauts back were not tested. But what they knew is that if they did nothing, these three astronauts would not return back to Earth. So they had to resort to untested techniques. But they didn't just resort to untested techniques without thinking them through, because the way we do things, the way that humans, the way we tend to do things when we're in a pickle, we don't just gratuitously do dangerous things. We think things through and you think, right, we're in a bit of a shitty situation here. Let's figure out what are the options, but we haven't got much time left. So I think, Adele, that's where we're at. I totally in an ideal situation, of course, we should work through getting things working perfectly, make sure we understand all the possible consequences. But I do feel strongly that we're going to have to learn by doing, I'm afraid. We don't have the luxury of doing experiments and working things out in fine detail. Now, it frustrates me that in that process of learning by doing, that we get people being saying, "Oh, this is terrible because you haven't shown that this is going to be safe." And I think one of the good things about what's happened in the Bay Area is that it's been recognized that the experiments that are being done are, they're not impactful in a bad way. So let's just get on and learn. This is learn by doing, and the same is exactly true in around the Great Barrier Reef in Australia. Learning by doing, and I feel that we should most definitely proceed and learn by doing.
Sounds good to me. Steve.
I just want to add a nuance to Hugh's comments that although we want to learn by doing, we want to do it in small scale, very small scale pilots to start with. And much of the work that I know Hugh is doing as his group and my group is looking at issues like the energy requirements for the delivery systems. And even with the current technology, the amount of energy that you need to deliver this is orders of magnitude lower than what you would need for, say, removing carbon dioxide directly from the air, which would be wonderful if we could just suck the CO2 out. But that is a case where you'd use a huge amount of global energy to operate the technology, whereas something like marine cloud brightening is something that, although it's an enormous scale operation, is very tiny by comparison to some of these other efforts. So I think we agree with the concerns that Adele has, but that's something that informs what we're doing. And without starting on the research, we will never be in a position of knowing enough to implement it. So we have to start thinking about it now.
Yeah. Dipping your toe in the water before you jump in is, I think, a sound policy. Danny Rosenfeld, please.
Yeah, we don't have much time, not only because the world is warming very fast, but because the development of the technology is very hard. Presently, the capability of spraying experimentally is such that we can hardly make a visible impact on the clouds with all the power that we can put in one experiment. I can tell from my experience in Australia that it was not easy to find the seeding signature in the clouds while flying with the airplane in the clouds. Sometimes we found it and sometimes not.
Sorry, what is a signature? You're talking to an ignoramus, so what do you mean?
It means to find the cloud which has a larger number of smaller droplets that can be attributed to the seeding.
Okay. And you can't do that just by flying through. You have to, what do? You capture a bottle full and take it and go home and count the contents, or what?
No, that is an experiment. We spray on the ship. We operate on the ship the spray machines.
Yeah.
The spray goes into the cloud, and then we take the airplane and fly into the cloud to see the expected effect. If we can't see it when we look for that, then of course it doesn't work. Yes, we did find it, but the scale over which it was actually manifested is by far too small for any even regional meaningful effect.
Oh.
And the machines presently are very they take a lot of energy for the spray. This spray technology needs to be much more efficient to become deployable in a large scale. And this is now a major engineering effort that is taking place, I know, in Cambridge. And Steve said that he's active in that. I'm working on that. Rob Wood is working on that. This is the main obstacle that separates us from between us and the ability to deploy it, even if we wanted. And everybody would tell us, go ahead.
It's the size, it's the nozzle, right? It's developing the nozzle that produces the tiny spray that you need, right?
I will say it more widely, develop the technology to down the water to the right size. Might be nozzle technology or other technologies.
What could it be? There's some other way? Okay. Tell me.
There are a number of ways that I will not go into that because these are engineering details.
Okay.
That's not particularly fair, because you could say that lots of different ways, but if you want to water your garden with a hose, then there's lots of different. You could drip the water into your garden. You could have the water coming up from underneath through the roots. You can have, we've been pretty inventive, and there are lots of different ways. The simplest way is the kind of one that you've seen perhaps in the videos from Australia, or something that looks a little bit like a snowblower in the mountains, blowing snow out to now that's kind of the easy way, but it consumes quite a lot of energy, and we've got to figure out how to do it more efficiently.
Yeah, it's a brute force way.
It's a brute force way, and
Okay,
you can.
Adele has another question or issue. Adele?
I want to know if there is any publication, and could you please, send it to us about the work in Australia? How it would be really important to be able to read about whatever the state of the art is, even though it's very early. That's one thing. I have to say, I just can't refrain from telling you that the professor who supervised my PhD was part of the team that saved Apollo 13. But anyway, that's not relevant to this. But I really think we need to to realize this a whole set of steps and get more researchers on board. I gather there are not enough researchers involved in this. If it's important, somehow uh, it needs a bigger effort.
Well,
Steve?
the research in Australia now, the last phase concluded in the end of last February, and now everybody is analyzing the data and working on the publications. And by the nature of things, we are not, as long as these are not finalized and some require embargo until it is publicized, we cannot talk much about what is there, except that the results are encouraging so far.
Oh,
Mhm.
okay. Steve?
I'd like to point out that society has been doing unintentional marine cloud brightening for over 100 years.
Mhm.
The sulfur in ship fuel has
Mhm.
contributed to formation, and in the last few years that has been removed, and the signature from that removal is actually observable from satellites. So it's a difficult thing to back out, but and then Daniel would know more about this than me, but I think the signature of that sulfur removal is visible, and it does support the general idea that there has been a warming. The removal of that sulfur has actually produced a warming effect
Yeah.
that, of course, will make the planet warmer thanks to removing that. And it was removed because the sulfur forms acid aerosols and deleterious effects, especially when injected close to land, where terrestrial systems are affected by the acid deposition. What we hope might happen is that effect would be added back in again without the deleterious effects. That is the marine cloud brightening without the toxic emissions. So I think there is evidence from those, let's say, opportunistic experiments, those natural experiments that can support this.
Right.
I want to refer to something that I've read on one of the HPAC discussions by Franz Weste, and he claims that this is very powerful evidence that the marine cloud brightening would work, because the fact that the sulfur content, reducing the sulfur content of the ships, and made them allow the ship flue gas to be emitted, and this surprisingly increased the temperature as a result, and it was really good proof that brightened clouds are very effective in changing the temperature. And he claims that this is going to actually be an argument in favor of the idea of hurrying up and allowing a marine cloud brightening, because already they allow toxic iodine compounds to be put into the clouds as a way of preventing hail, even though hail damage is very little in comparison to how important climate heating is. And so he thinks that when they realize that climate heating is so important, and that this is clearly evidence that we can do something about it, they're going to be allowing non-toxic and eco-friendly salt aerosols to be sprayed into the maritime atmosphere pretty soon now. And so I wonder whether any of you agree that this is a good case or a good piece of evidence to adduce in any dispute about the safety of marine cloud brightening.
Well,
Danny,
what body is going to allow it? I mean, who gives authorization for this kind of thing?
well, Danny Rosenfeld, you have your hand up, and what do you want to say about it?
Okay. Well, first of all, the silver iodide seeding is not toxic, but it was allowed because it has only very limited effect in time and space. But the concern is about effects that might affect the global climate, and that is something very different, which requires a global governance. And that addresses Adele's question, who will allow this? And now presently there is a consensus that it should not be done with, that any activity that affects the global climate should not be done with global consensus. And you know how difficult it is to reach global consensus. But back to the effects, to the field effects of the marine cloud brightening, the fact that we are undoing marine cloud brightening inadvertently allows us just to look back at what happened in the past for the side effects, and that limits the possible fear from unexpected side effects.
Okay. Yes.
So I think that the what we've learned from the Great Barrier Reef is that engagement with the local indigenous peoples, which they've done very carefully over the last 10, 15 years, is very, very important. Because the local indigenous Aborigines that live and fish on the islands around the Great Barrier Reef, well, they know what's happening, and they are as devastated as anybody that the reef is being damaged. And the idea that there is a group, a consensus of scientists and indigenous people and social scientists and politicians and economists that are all working to figure out, with all part of this reef restoration and adaptation program, RRAP, RRAP, and which, by the way, has just got its new round of funding for further research, which is fantastic. So you ask who gives permission for this? Well, you know, Dan Harrison and his crew are off. You know, they've been doing multiple experiments in the waters around the Great Barrier Reef, all under the auspices of Australian government-funded research supported by the local Indigenous people. And they're learning a lot. They're learning a lot. And it still is dipping their toe in the water, but they're learning a lot. So if I then think, well, can we translate that to the work that needs to be done, say, to refreeze the Arctic, work that needs to be done, marine cloud brightening, perhaps, to save the Arctic sea ice? Well, it's a little bit unfortunate that the last 100 years or so of dealing with the indigenous people in the Arctic, there's been a huge amount of lack of trust and lack of engagement. So there's a real work to be done to get the same positivity that's really been a hallmark of the work going on in the Great Barrier Reef, to get that positivity engagement, to get that back again, so that the work that we might want to do for everybody's benefit to try and safeguard the ice in the Arctic can be done without who's gonna give permission? Who's gonna say yes, you can do it? Well, if everybody wants it, it makes it much easier. And I feel we need to learn from what we've seen in Australia.
Steve.
Another point about marine cloud brightening that I think does relate to Adele's question about governance is that the aerosols that you inject in marine cloud brightening don't last in the atmosphere that long. You're talking about days or weeks, and they're all gone. That contrasts with some other suggestions for solar radiation management, where you'd be injecting things higher in the atmosphere, and you're talking about months or years before uh, the effect of the experiment disappears. So, marine cloud brighten is in some ways very suited for dipping your toe in the water, seeing what the effects are, and then moderating your technique as you learn more. So it is one where you can learn as you go and improve where you inject the aerosols, understand what small effect they're having in an area, and then change course. These are not persistent. And I think that is one of its biggest strengths. It's
I
also a
totally agree.
weakness in that you have to keep injecting the aerosols to keep having the effect, but that's a benefit. And as soon as you decide you don't want to do it, well, in a few days the effects are gone. So,
but you did mention along the way there, Steve, that it's regional, that it's local, whereas stratospheric aerosols is almost, it's a hemispheric thing. If you start doing it, you do it for the whole of the northern hemisphere. Whereas the work that you might do with marine cloud brightening for the Great Barrier Reef is a regional thing, which I think from just the way we think about it makes it feel less risky.
Also, the reality is that some of the Arctic is inside national boundaries. I mean, we could do experimentation inside Canada, which would make it a lot easier than having to consult all the countries in the world and get consent to it. Because if it's just a Canadian project, I think national sovereignty would be trotted out as an argument. But one thing that Hugh said, I want to explore. You seem to imply that the Aboriginal people of Australia are in favor of this. My concern is that I've been hearing more about how there's an effort to integrate and bring together. In fact, there is a movement or an organization now forming of Indigenous people worldwide, and there's an effort to try to get them to take a very strong statement that they oppose geoengineering under all circumstances. And I know that one of the problems in Canada with the Indigenous people is that there is a tendency for the elders to oppose any kind of climate change technologies. So the claim that we've got to get everybody to agree to it, and if everybody would agree to it, it would be easy. That's true, but I'm wondering whether it's even possible to get everybody to agree to it if there is this reaction among some Indigenous people, and I wonder how widespread that reaction is.
Okay, I think that it is not an issue yet. Because we are incapable of inducing global impacts that will have global effects on the climate because of technology limitations. But going again to the governance issue, a simple criterion would be that anything that you do that does not affect your neighbors would be permissible. And that is exactly what is happening at the Great Barrier Reef, because the scale there is, actually, the Australians say, don't call it geoengineering. We don't intend to do any climate change. All that we want to do is protect the Great Barrier Reef and cool a bit the water there to prevent the coral bleaching. That's all. But an important byproduct is developing the technology for geoengineering, and that is a blessing. And that is okay because the scale of the activities there is incapable of affecting any of the neighbors of Australia, much less the rest of the world. But if we go to the Arctic, and try to prevent the melting of the ice in the summer there, the sea ice, that will have global effects.
Mhm.
Therefore, it is a completely different question of governance and global consensus.
But I think that I totally agree with that. The regional, it's not going to affect your neighbors. But then this question about are all of the Aborigines in Australia, all the Indigenous people in Australia, supportive of this work? I didn't say that, but you might have inferred it.
I did.
The people in the great region of the Great Barrier Reef are very supportive of what we're doing, or what they are doing. Now, I have no idea. Australia is a big nation, and so if a consensus were to be reached, so I've heard this before, Meta, and the idea that the indigenous people of the world are being drawn towards concluding that there should be a ban on geoengineering, or there should be, whatever it might be. That I really want to see that is informed, and that the consequences. It is very easy to say, "Oh, I don't want anything nasty like chemotherapy, or I don't want some nasty, I don't want any of that." But if the alternative is, oh well, if you don't have that chemotherapy, you're not going to live very long. You might not see your grandchildren. Well, that's it's not a very good analogy, but it kind of helps.
Better analogy.
It helps to concentrate the mind, and I feel as if when we talk about the world's indigenous people, I do worry. For instance, when the ScopeX project was put on hold in Sweden, that it was the Sami people that seemed to have the say in that. But I don't know what the people in the Maldives or Bangladesh or Fiji might have said had they been asked, because they're the ones that are going to be most impacted in the near future because of sea level rise, because of the melting ice. I'd like to think that they were at the table when the discussion about the ScopeX project the decisions about the ScopeX project were being made. So I think when we talk about some global consensus of the indigenous people in the world, we've really got to be a bit careful to make sure that it really is a consensus.
Yeah, I'm working on that. I'll tell you more whenever I put together a meeting involving some indigenous people. But I've had some indigenous representation in previous meetings, but I think we need a new one, a larger scale one. Yes, I think Danny Rosenfeld is wanting to speak, and then Adele.
Just going to another medical analogy. The world is sick. It has rising fever, rising temperature, because of because of a basic illness. So if somebody is very sick and he has a fever, the fever, if he doesn't get medicine to decrease the fever, might kill him before the antibiotics might cure the root cause of the illness. And I think that we should use such an analogy. And we should develop that medicine to decrease the fever, should we really use it and not get stuck without it and then get killed because we don't have it at the right time.
Adele?
Now, as to the different perspectives of different indigenous people, just take the people in the Maldives and their neighbor Indians. when you reflect more solar energy from the clouds over ocean, you have less energy available to evaporate water from the ocean, and respectively, you have less vapor available to be transported over land to produce the monsoon rain, for example, over India. So here you have the contrasting interests. Are we going to pay for less sea level rise with less rainfall over India? I'm not going to answer that, but these are the issues. This is an example for the issues that will have to be resolved and agreed on.
Thank you. Adele?
Yeah, well, I'd like to kind of, sorry, address the problem of working in the Arctic. Who knows why? I just anyway. It's a very difficult environment and very expensive to work in. And what that means is that proving something in the Arctic should wait until it's further developed. I mean, I realize that we really would like to see the Arctic refrozen, but right now, the temperature of the water in the summer would immediately melt any ice that you created before you could probably find out what was going on. If you tried to work in the Arctic, you would have to supply absolutely everything you ever needed because there are no facilities to speak of. That is, so you cannot get anything else from nearby. The Arctic is extremely remote. In in Canada, and certainly I don't think the Russians are very keen on any of this. They have more facilities, but it's better to get a lot more ready to go to the Arctic, where you can have some hope of having an effect, rather than experiment there where it's extremely difficult. And another thing to remember about the Arctic is, okay, let's try to form some ice when it's getting the end of summer, so it'll stay. Well, that's the end of summer is also the time when it starts to get really dark, totally dark. You're not even going to see any clouds because it's so forbidding. So all you could do is make some ice, hope that it stayed until spring. When it is to my view, non-productive to work in the Arctic at this point, even though we wish that we could have more ice.
Okay, Hugh.
Well, we're there now. And we are working with people in Cambridge Bay in Canada. And of course, what you want to do, the first step is to slow down the rate of melting of existing ice. It's not about going into an open ocean and making an ice cube and hoping that it stays. The ice that's there at the moment is melting. But what we're doing is we're doing various projects about how to thicken the ice, so that, and we do that right the way through the summer. And then during the winter, there's also experiments that we are currently in the process of doing, which is to thicken the ice in the winter as well. So in the summer, you're trying to slow down the rate of melting, and the winter, you're trying to increase the rate of freezing. And bit by bit, we need to increase the extent of the ice.
You haven't said
to say that we shouldn't be doing our experiments there now because the Arctic is too intimidating. Well, we're there now.
Yeah, what are you doing there? You obviously have to use different technologies in the summer than you would use in the winter. Can you give us, I presume you're not doing anything like marine cloud brightening as any of that.
So at the moment, the work we're doing is on ice thickening. So it's how to, in the winter, how to make the ice thicker, so that it then we come back into the summer with more ice than we might otherwise have had. We're not doing the marine cloud brightening stuff there yet, but we certainly have access to places to do these things. I'm not sure that I agree that it's all about going to an intimidating, completely impossible place. The work that we've been doing there, what was quite funny was that we had to get through all of our minus 40 degrees, and we had to go through all the training and wearing all these special suits for Arctic survival suits. And there's a nice picture of my team on the ice, all in their Arctic survival suits. And then a bell rings, and then all the school kids come out at lunchtime to see what's going on, and they're running out on the ice in jeans and t-shirts. But they're all interested. They want to know what we're doing. And actually, we're not there right now, but they are carrying on doing the measurements. The local community there are carrying on doing the measurements on the work that we've been doing. It's for me, this is the way we've got to be moving forward. Take advantage, as they've done in Australia, take advantage of local enthusiastic communities and work with them. And let's not wait around for international global consensus.
I would thoroughly agree. Adele, I don't want to give you the last word, but almost the last word.
Well, I try to be quick about this, but I think that the work you're doing is to add water to the ice, and the ice freezes it, and therefore you get thicker ice.
No, that's not correct, but there's not enough time to go into the detail of that.
Okay, well, because if you were trying to do that, you need the latent heat of fusion, which
That's
sure
why I'm
you
saying
know.
it's not how it's working.
Not that. Okay.
We are scientists and engineers. We have thought this through.
Yeah. I want you to come back with your team and talk about that sometime, because we haven't done a show about that particular project. That's terrific. Now, who gets the last word? I want to give it to somebody. Steve, you haven't expressed too much of an opinion on things, so why don't you get the last word?
Well, I don't know if it's the last word, but I'll just say thank you, Meta, for organizing this discussion with diverse opinions. I think that governance is a big issue, and communication of what's going on is a huge issue. And it's important that there eventually be a consensus, but it has to be informed consensus. And so if we don't have people with diverse views talking about this, we'll never get there. So thank you very much.
Well, it's my hobby. I just love doing this, and it's more fun than anything I've ever done before. So I think I'm glad to know that it's also sometimes useful. And I can't think of a topic that's more important to try to cover than what we've been discussing. So we will come back at it again and again, and different cast, but the same play in a way. So thank you all, and I'll be back in touch with you sometime soon.